It means there is a new substance will be formed, new chemical reactions are there, but when it remains with quantities, in terms of quantities, they remain the same. That's called the law of conservation of mass, or the law of conservation of matter. The same way, we have something called the law of conservation of energy. That means the total energy of the system doesn't change. Energy, in other words, cannot be created or destroyed. In other words, a potential energy can be changed into a kinetic energy. A kinetic energy can be changed in a potential energy. How do we explain this fact? This can be explained as following way. Very simple physics example I can give you to understand the law of conservation of energy. Say, for example, you have hill here, and you have a guy here. A guy stands here, okay? Maybe a guy has a bike. Okay, this is, okay. Energy, the kinetic energy is going to be some energy here, okay? But the potential energy is going to be zero. So what is the concept here? The concept is whatever energy we have here on the top, which is the potential energy, is going to be the same as the kinetic energy at the bottom. Which means kinetic energy is reserved or conserved. They call it conserved. Nothing is lost. In other words, the potential energy on the top is the same as the kinetic energy at the bottom. Just like when you do a chemical reaction, the Dalton atomic theory says, for example, you have zinc reacts with hydrochloric acid, gives you zinc chloride plus hydrogen. This is a simple chemical reaction, right? This is what type of reaction, if I ask you, what type of reaction is this? Which is it? This is called a single replacement reaction. A single replacement reaction. The reason why single replacement, because zinc, a metal zinc, replaces the hydrogen gas here, and we get zinc chloride, new substance, right? And hydrogen. What happened in this reaction? What is happening? Chloride is switch, and what is happening? What is it, a chemical change or a physical change? It's a chemical change, of course. This is a chemical change, right? Now, the point is, it's a chemical change. The point is, in terms of quantity, in terms of amount, you have like X amount of zinc, Y amount of hydrochloric acid. Over here we have a new substance. However, over here we have a new substance, but the amount remains the same. Okay, if you start with 50 grams of zinc and hydrochloric acid, you may get 50 grams of zinc chloride and hydrogen. You may get 50 grams, the same amount, the same quantity. What do we call this? This is called the law of conservation of mass, right? Nothing has lost. Do you understand? Nothing has lost, nothing has disappeared. This is the same for with the energy, the law of conservation of energy as well. So now the question is, how do we measure energies? Okay, how do we measure the value, the quantity? Because energy is a physical quantity, just like you measure temperature. How do you measure temperature? You measure temperature either in Fahrenheit, for example, in Celsius, or in, what is the SI unit for measuring temperature? Kelvin. Kelvin is K, right? We have to measure energy in terms of calorie. Okay? Calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree centigrade. That is the unit that's used to measure calorie. Okay? And the standard unit, 1 calorie, equals to 4.184 joules. That's what 1 calorie equals to. 1 calorie equals to 4.184 joules. There is also other units like 1 kilojoules. Okay, 1 kilojoules. What do you think 1 kilojoules will be equals to? 1,000 joules. Okay, 1,000 joules. We have also like 1,000 calories. 1,000 calories equals to how many kilocalories?
1 kilocalorie.
Yes. 1 kilocalorie. These are, you have to be familiar with these units. These are the units that we will be measuring the amount of heat released or produced. Okay. It's not only that, the amount of stored energy in food is measured by using nutritional calories. Okay, the nutritional calories is measured in thank you. So the nutritional calories has to be measured by uppercase C. 1C, okay? 1 calorie, which is the upper C, the small c and upper c. The small c is just like what we have here. The upper c, 1 calorie is equals to 1,000. 1,000 calories. Okay, so 1,000 calories is basically equals to 1 kilocalories. Okay, 1 kilocalories. So these are the things that you should be familiar with, and we can do some calculations. Like if you have metabolisms, say for example, how much proteins, how much carbohydrates and fats can be released. Sorry?
I have a question, please.
Yes.
You said 1 calorie equals 1,000 calories.
1 calorie, 1 big C equals to 1,000 small calories.
What is the difference between big calorie and small calorie?
The big calorie, the C, is nutritional value for nutritional. Okay? But the smaller one is for anything else. It can be for a chemical reaction. It can be for anything. But like let's say, how much calorie you get from protein, how much calorie you get from carbohydrates, how much calorie you get from fat, okay? They are represented by the upper, that is the nutritional predictable energy that is used to measure caloric value. Okay, so we use big C, yes?
But number 1 calorie is the same as 1,000 calories?
Yeah, 1 big calorie, 1 big C equals to 1,000 calories.
1 calorie.
No, yeah. 1 calorie, it is like the symbol for 1 calorie is 1C.
Oh, it's the same thing?
It's the same thing, yeah.
Oh, okay.
But 1C equals to 1,000 small CAL, like this. This 1,000 CAL. That's what it means, okay? Of course, that how much calorie you get from proteins, how much calorie you get from carbohydrates, and how much calorie you get from fat is given to you. Protein per gram produces 4 calories. Carbohydrate produces 4. Fat produces 9 calories per grams, okay? This also on the test. I'm not going to ask you to find this, but what I'm going to ask you, maybe I'll give you certain values here. Maybe we can do this example together. If you have a pen and a paper, you can write this. If a baked potato contains 3 grams of protein, write this down, 3 grams of protein, and 23 grams of carbohydrates. You have a baked potato, that potato contains 3 grams of protein and 26 grams of carbohydrates. So my question to you is estimate the number of calories. How many calories that you get from 3 grams of protein and 23 grams of carbohydrate?
You said 23 grams?
I'm sorry?
26 grams or 23?
26 grams? That's wrong.
No, I said, did you say 26 grams?
No, 23 grams. There is 23 grams of carbohydrates that baked potato will provide me. So the question is, I wanted to know the number of calories, the big calories. I wanted to know how many calories would I get. So how do you answer this question?
Multiply 3 grams by...
How do you answer the question? First of all, protein, 1 gram of protein provides you how many calories?
4.
4 grams. 1 gram of carbohydrates provides you how many calories?
4.
It's also 4. So how many grams of protein you have?
3.
You have 3 grams of protein, and you have what? 23 grams of what? Carbohydrates. So the total amount of calories you get will be what? You multiply 3 grams, right? Times 4 calories per 1 gram. plus, right, 23 grams times 4 calorie, because 1 gram of protein provides 4 calories of energy. If I have 3 grams of protein, okay? Yes, and 23 grams over 1 calorie. So what would be the total caloric value? 104, yeah. It should be 100, let me see, it should be, yeah, 104 calorie. We'll get 104 calories, okay? Big C, yes, big C, because we're talking about the nutritional value. That's the difference. The 3 states of matter. Now, when we discussed about kinetic energy, I think from chapter 1, we discussed about the physical states of matter, right? Gas, liquids, and solids, right? Now, how do you explain, in terms of the kinetic energy, kinetic movement of molecules, how do you explain gas, liquids, and solids? You see, like, I don't know if you I'm sure you remember that matter is divided into a pure substance, right? A pure substance. A pure substance means like you have a mixture, you have a pure substance. That's according to the composition. Based on the composition, matter can be divided as pure substance or as a mixture. Again, pure substance is divided in terms of either it can be a compound or it can be an element. This is how we classify. Based on the molecular movement of matter, matter are divided into 3 sections. What are they? Solids, liquids, and gases. You see, this is the 3 classifications of matter. So what is the basics here? What is the criteria here? The criteria for defining matter is kinetic molecule, is a kinetic energy, because kinetic energy is always related with the motion of energy. So in gas, for example, kinetic energy is high because the particles are very much apart each other. So gases, that's one of the reasons that gases do not have shapes and volumes, right? Because the attractive force between molecules are negligible. There is not that much attractive force. In liquids, the attractive force compared to gases is less than the gases, okay? They are very much closer together. So the distance between the molecules and the kinetic energy is much less. So molecules basically have volumes, but they don't have shapes. Their shape is always depending on what? Depending on the shape of the container. Very good, the container. When it comes to solids, there is a great attraction force. The attraction force between molecules are even very much stronger. The distance between particles is smaller, and you can say there is a little freedom of motion. You can say that there is really high attraction between molecules, between particles. So we can expect that a geometry, solid geometry or a regular shape in liquid. So in solids. So the kinetic movement is not great, or it's not high compared to what? Compared to the liquids and gases. Now, when we discussed about boiling points, melting points, and you can see that the boiling points of solids sometimes is stronger, right? So, for example, the boiling point of, if you want to boil sodium chloride, what is boiling of sodium chloride means? You want to change the solid sodium chloride to liquid, right? That's what boiling means, right? Yeah. Sometimes, did you ask yourself why some substances have less boiling point, why some substances have high boiling point? Where does that come from?
The energy.
Well, the energy, yes, you have to invest energy. But the question is, why do, for example, water boils 100 degrees centigrade? That's the boiling point. Standard water is boiling in 100 degrees centigrade. If you take sodium chloride and you want salt, common salt, you want to change the salt into liquid, it boils up to, it needs up to 800 degrees centigrade. 800 degrees centigrade. So where does that come from? Why is that difference? I'm sorry?
Does it have to do with the bone?
this is actually the bond. This is the attraction of the particles. Okay, the attraction between water molecule and water molecule. You see, sometimes you have water has okay. Boiling means like there is a bond here, right? This is the liquid water, because water is made from H2O, H2O, H2O. You have to break up this bond. This bond has to be broken down. This bond has to be broken down in order for you to change the liquid water into gas. That's how boiling means, right? Whereas you have sodium chloride, sodium plus Cl minus, and sodium plus Cl minus, sodium plus, there are infinite numbers. There is also a bond here. Okay, in most cases, the attraction bond between one molecule of sodium chloride to the other molecule is stronger here. It's like ionic bond, right? The bond here is not stronger, like actually when I picture this might not be a good picture because oxygen has a partial negative charge and hydrogen has a partial positive charge. Okay, so the attraction is always plus to minus. Okay,
so is that why hydrogen bond is considered weak attraction
compared to the ionic bond? Okay, there's not only in this chapter we're going to discuss about hydrogen bonding. We're going to discuss about ionic bonding. We're going to discuss about something called London dispersion forces. We're going to discuss about dipole-dipole interaction. These are responsible actually. These are responsible for the boiling point, the melting point of substance or molecules. So we have London dispersion force. We have dipole-dipole interactions. We have hydrogen bonding. Hydrogen bonding is especially in the water molecules. So the strength of the intermolecular forces is determined which compound has a high or a low melting point. Okay, so some substances have high boiling point, some substances have low boiling point. That actually comes from based on the strength of the intermolecular attractions. Okay, between the molecules of sodium chloride and sodium chloride, between water molecule and water molecule. If they are strong, then they are going to have strong boiling point. If they are weak, they are going to have less boiling points. A London dispersion force. It is very interesting that we have a London dispersion force. London is, by the way, it's the name of a person. Okay, a name of a name of one chemist who find out this. A London dispersion force can be created by a partial electron charges. You know, sometimes where are electrons? Electrons are around the nucleus, common sense, right? Electrons are around the nucleus, but where? We don't know, because they are 24/7 in stationary, right? They are always in a movement. If you just take a shot, a quick shot, a snapshot, in other words, there will be at some point, on one side, there will be like huge amount of electrons. On the other side, there will be less amount of electrons, because electrons have freedom. Electrons are free to move every time, 24/7. The movement is not symmetrical. The movement is not like 50-50. At one point, you may have billion number of electrons on this side. At one point, you have very less amount of electrons on this side. That condition is good for London dispersion force. A huge density of electrons on this side creates a partial negative charge. A less number of electrons creates a partial positive charge. You see, now we are breaking the law. If you follow, we are really breaking the laws. The law says that positive and negative charges are always, attraction is always between two oppositely charged particles. That is like traditional way of saying it, right? However, London dispersion force arguing that there will be attraction force between the same charges. If you think about that, there will be attraction force between the same charges. He said there will be attraction between electrons and electrons. That attraction is actually hold the molecules like covalent compounds, most polar compounds, you see. Ionic compounds, you don't have any problems. Ionic compounds are always formed between metals and non-metals. You always have positive charge and negative charge, right? In covalent compound, you don't have positive and negative, right? So what kind of force holds them together? A London dispersion force. A London dispersion force is responsible for covalent compounds. It is a weak, of course. How it's induced, how it's created? It's created by the distributions of electrons. Huge number of electrons on one side creates a partial negative charge. Less number of electrons on the other side creates a partial positive charge. That holds them together. So all covalent compounds, they exhibit London dispersion forces. And London dispersion forces, of course, is very much weaker. It's a weaker force. That's why the most organic compounds are volatile. Volatile. What does that mean? They can easily be evaporated. You see why they can easily be evaporated? There is no attraction force to hold them, to tie them. They can easily be evaporated. Most organic compounds are easily flammable. They can easily be burned with oxygen. That's why when you do in the lab experiment, I always say, or in my class, or any chemistry instructor tells you, please remove the acetone, remove the alcohol, remove the benzene, or remove anything next to Bunsen burner, because it's easily volatile. It can easily catch fire. Why? London dispersion force. Because the force of all covalent compounds, they experience London dispersion forces. And another factor that we should know is that the larger the molecule we have, there is a larger attractive force, because there is going to be strong intermolecular forces. In other words, if we studied names, right, last class, names of compounds, right, like name. One, yes, from chapter, like for example, what is the name of this compound? These are organic compounds.
We didn't say organic.
Oh, we didn't do organic. Okay. Okay, these are organic compounds. So what kind of force that, this is covalent compounds actually. All organic compounds are covalent compounds, okay? They are not ionic. So the type of, what type of force they experience is actually they experience a London dispersion force, a weak force. So if you compare, this is called propane. This is called butane. Propane, butane, pentane, it continues like that, right? Pentane means 5. Pentane means 5. So if I have C5H12, yes, that's pentane. Okay, also ANE also tells me something about what families they are. This is, in organic compounds, suffix always provides you an information. ANE means alkane groups. Okay, alkanes are the saturated groups. Now, if I compare C3H8 versus with KCl, these two, okay, in terms of boiling point, melting point, in terms of molecular attraction, this one is much stronger than this. Because there's ionic bond here, okay? The boiling point is higher, the melting point is higher, this is not volatile. That's why you can leave sodium chloride open air, nothing will happen, okay? But this is like more volatile because it is organic compound. Okay? Organic compounds are the chemistry of, we call organic compound the chemistry of carbon and hydrogen, okay? The chemistry of carbon and hydrogen. Of course, and one other thing I want you to understand here is that if you compare between two organic compounds, the larger molecule that you have, I brought these two compounds, the C3H8 and C4H10. Which one has a higher intermolecular force? The butane, yes. The ones that has a higher number of atoms. Always, the more atoms, the more number of protons or electrons you have, the attraction force also increases. Please remember this. Okay? The more number of molecules you have, you will experience the more attraction forces. It's also another fact that I want you to take into point. The more number of molecules you have, the larger the molecule you have, there is a larger attractive force, and the stronger will be the intermolecular forces. The stronger will be the intermolecular force. In other words, C4H10 has a higher boiling point and a higher melting point than C3H8. If I have C5H12, higher boiling point and higher melting point. Okay, compared to C3H8. Intermolecular forces or London dispersion force is clearly seen how it's created here on the PowerPoint presentation. Unfortunately, the light was burned out, so we can't able to do anything, but I'll show that to you next week, okay? And how London dispersion force is created. So we have also a dipole-dipole interaction. A dipole-dipole interaction is also it's an attractive force between the permanent dipoles of two polar molecules. Okay, that means well, that might not be a good example here. I can give you. How many of you have your PowerPoint? Your PowerPoint with you? Okay, if you have a PowerPoint, did you see the dipole-dipole interaction? I think this is slide number 12, I guess. There is a formaldehyde force. Formaldehyde chemical that shows you it is between the attraction between oxygen and carbon. Okay, oxygen is electronegative. Oxygen is higher in electronegativity, as you know, right? Because oxygen is found on the, where do you find oxygen? Here. Right, on the right side, okay? Always, whenever we have elements on the right side, their electronegativity value is going to be higher, right? We have carbon here, it has a less electronegativity. So, there will be an attraction force between carbon and oxygen. A partial negative charge, a partial positive charge. Compared to oxygen, nitrogen has a partial positive charge. I'm talking about the electronegativity, okay? Compared to oxygen. I know nitrogen is a negative element, but compared to oxygen, more negativity is on oxygen side and less negativity is on the nitrogen side. Less negativity on the nitrogen side implies that positively charged for the nitrogen side compared to oxygen. Okay? That creates something called a dipole-dipole interaction. A dipole-dipole interaction. Hopefully next week this will work, and then we continue next week, okay? My suggestion is to you, please arrange this PowerPoint presentation. When I go to my office right now, I will upload that for you. Right now, when I go upstairs, I will upload that for you. Chapter 4, okay?